Today I'm going to demonstrate the Measurement Specialties Model 121 Precision Low Noise DC Amplifier. In this case I've hooked up one of our Measurement Specialties piezo-resistive accelerometers. It's unamplified and has a full bridge. It's a 3801. It's rated for 50G full scale, and I have the 121 already programmed for it, so we can look at the performance. As you can see, it's sensitive to gravity, sensitive to shock. The first thing we'll look at on the 121 is the back panel. We're looking at the rear panel now. Just to walk through it, we have a power switch on and off. It's fused. We have a selection of power cords that allow 110 volts AC at 60 hertz or 220 volts AC at 50 hertz. We see 3 channels. We have the first channel plugged into our 3801. The input channel is a DB9 connector. The output channel is a BNC. Here we're looking at the front panel of the 121, and here we have the user accessible programming features as well as a display which shows the output of the device when properly set. Just as a demonstration, as I do a flip test in gravity, you can see the voltage changing. We're currently in the monitoring state, but I can individually select each of the channels and set its programming. In this case, it's at channel 1, and just hitting the button, I can go to channel 2 and channel 3. There's also a set of lights that show a fault condition should they occur, and that could happen if you overrange the input to the 121. Now for the programming features, we go over to the select function, starting off at the 10 volt excitation, which is currently set. That can be changed to 5 volts by simply hitting the buttons here. You can move the decimal place, the numbers, and hit the button in the middle to set the excitation once you're satisfied. We can go to sensitivity. There's actually 2 ways of setting gain. One, you can normalize the output to a sensitivity that you want, or you can simply input the gain. The first thing we'll look at is inputting the sensitivity device itself and indicating what sensitivity we want from the 121. In this case, I've already inputted the sensitivity of my 3801, which happens to be 1.025 millivolts per G. Again, these are set with the buttons. Now for the output, I want an output from the 121 of 100 millivolts per G, which I've already set. And if I go to my monitoring state, once again, you see about 100 millivolts per G. The next function that I can do as far as setting gain, in this particular case, the 121 actually adjusted the gain setting just by the input I've had for the sensitivity and the output scaling, and came up with a gain of 97.56. Now I can override this in this particular function by inputting the gain itself, once again using the buttons. There's also low pass filter function. It's currently on. In this particular box, the low pass filter is set to 10 kilohertz. I can turn that off by hitting enter. So then I get the broadband output of the device of the 121, which happens to be 200 kilohertz. There's a selection of modules which can plug into the device and that the user can insert. And there's a selection of values for the filter corner. Let me now demonstrate the auto zero function, which is the next one down. And at this point I have the auto zero function turned on and it's ready to actuate. And what I did is took the 3801, we'll move it on its side. I deliberately offset the zero so you can see the auto zero taking place. So here I hit the actuate. And it'll take a couple of seconds to actually perform the auto zero function. And it'll indicate success. So at this point, you can see how I've normalized the output as I do a flip test. And that's a demonstration of the auto zero. Another function that we have is for shunt calibration. It's a rather unique feature. Built inside the box is a 100k ohm resistor, which can be inserted into any of the 4 legs of the bridge just by hitting the buttons. A shunt calibration resistor can also be connected externally. Finally, there's a monitoring state, which we've seen before, but we do have the capabilities of looking at the DC output, which we're seeing right now, or we can change to an AC output. So essentially in this case we're looking at noise and it responds to shock. This concludes the functional demonstration of the Model 121.